Today we're going to be learning some introductory knowledge needed in the next couple of lessons when we get to solving equations. Today we're going to be learning about three important properties of logarithms. We're going to go through and look at their formulas and then apply them to some examples. So the first property of logarithms is the product property. So with this property, when you see one log with two items multiplied together, these two can split apart into two separate logs with an addition sign. So what's important to remember when you're splitting them apart, multiplication is going to change to addition. So one log with multiplication changes to two logs with addition. Now we're also going to be using these properties the other direction. So if you see two logs and they are added together, you can put it back as one log with multiplication. So multiplication and addition are partners when it comes to log properties. The quotient property. So this property, when you see one log and there is division involved, it changes to two logs with subtraction instead. Now it is important to notice the one that's on the top comes before the subtraction. The one that's on the bottom comes after the subtraction. So division changes to subtraction. The other way works as well. If you have two logs that are subtracted, when you put them back together, it becomes division. Anything before the minus goes on top. Anything after the minus goes on the bottom. And finally, the power property. This property says if you have a log and the thing that you're taking the log of has an exponent, that exponent can shift to the front of the log. So it simply drops down here in front and changes to multiplication. And again, the other way around, if there's a number in front, you can bring it up as an exponent to go back the other direction. So we're going to look at several different types of examples that use these three properties. So this first property, or this first example, you are given some information up front. You are told that log base 9 of 5 is approximately 0.732 and log base 9 of 11 is approximately 1.091. So we're going to apply log properties that we just saw to approximate the answers to these three problems. So when you look at this first problem, do you see any of your three properties? Well, if you look, you see division. Since this is division, we're using the quotient property. Division is going to split apart into subtraction. So now instead of one log, there's going to be two logs, both with a base of 9. There's going to be a subtraction sign between them. The one on top goes first. The one on bottom goes second. So that's how easy those properties are to apply. Now the difference is we're not done. But now we can make some substitutions. Do we know what the answer is to log base 9 of 5? Yes, we do. It's 0.732. Minus, do we know the answer to log base 9 of 11? Yes, it's 1.091. Then, all you have to do is pick up any kind of calculator and simply type in 0.732 minus 1.091, and you should get negative 0.359. So, that's very straightforward. Let's look at B. Does this look like any of our properties? Well, we don't see multiplication, we don't see division, and we don't see an exponent. So no, we don't. The problem is we got to fix it. So here's the question you need to ask yourself. The number 55. Can I use 5 and 11 to somehow get 55? And the answer is yes. If you take 5 times 11, you get 55. So I'm going to make a substitution. I'm going to keep this part all the same. Instead of 55, in parentheses, I'm going to put 5 times 11. So does that look like one of the properties? Now it does, because that's a multiplication sign. So with multiplication, remember multiplication changes to addition. So 2 logs, both with base 9, with a plus sign between them. 5 goes with one of the logs, 11 goes with the other one. Now we're going to do the exact same thing we did over here. Log base 9 of 5 is 0.732 plus log base 9 of 11 is 1.091. Pick up a very simple calculator, type in that addition problem, and you should get 1.823. So this one, we had to do an extra step. It wasn't in the form we needed. We had to change it from a whole number to a multiplication problem. So let's look at the next one. Log base 9 of 125. Again, this one's like B. We have to figure out how to make it work. Well, we have 5 and 11. Again, those are the only 2 numbers you can use. So 11 doesn't go into 125, but 5 does. Okay, as a matter of fact, if you take 125 and you divide it by 5 and divide it by 5 again, you end up with 3 5s. 125 is the same thing as 5 to the power of 3. And if you don't believe me, check in your calculator. 5 to the power of 3, you should get 125. So what property does this look like? Well, this looks like the power property. So the power property says this number can come down here in the front. So it becomes 3 times log base 9 of 5. So now we can make that change. 3 times this guy right here is 0.732. Do your multiplication in your calculator, and you should get 2.196. So I'm going to have you pause your video, and I would like you to try these 3 parts to see how you did with these. Okay, so let's see how you can do now that we've tried one together. So your givens are that log base 4 of 6 is 1.292 and log base 4 of 10 is 1.661. So the only numbers you're allowed to use are 6 and 10. So our first problem here is log base 4 of 60. Well, how can I use 6 and 10 to get 60? Hopefully you said multiplication. You should have started off by making this 6 times 10 to use the product property. Split it apart. Log base 4 of 6 plus log base 4 of 10. So 2 logs, plus sign between them. One goes with 6, one goes with 10. Now you just got to plug in your numbers. So this one looks like is 1.292 plus, looks like this one is 1.661. Put those in the calculator, add them up. It looks like you get 2.953. So that one was just like part B on the first example. Okay, so then we get to this one. This is the most challenging of them because this is a division problem, which is good, but that's a 3 and a 5. And we're only allowed to use 6 and 10. Well, hopefully, most of you are thinking, wait a minute. I can just multiply the top and bottom of this fraction by 2. And yes, it's okay to do that because it's the same number. You can't multiply the top by 2 and the bottom by 4. But you can do the same number to the top and bottom, and you're good to go. And what that becomes is log base 4 of 6 over 10. So yes, that was the challenging one. So if you didn't try it, now that we have it as 6 over 10, go ahead and try it and get this one finished up on your own. So you should have noticed, well, this is division. So we're going to make 2 logs. Log base 4 of 6. Division changes to subtraction. Log base 4 of 10. So you should have filled in this one with 1.292 minus, fill in this one with 1.661. Calculator, subtract, you get negative 0.369. So we have one more example. Hopefully you looked at this one and you said, well, I know 36 and 6 are related. Hopefully you realize this was just like our other part C. 6 to the power of 2 gives you 36. So we're going to make that 6 squared. So then you can use the power property and drop that 2 in the front. 2 times log base 4 of 6, which then I can make that final change 2 times 1.292, and I get a final answer of 2.584. So that is these 6 problems we've done are like some of your homework. So let's look at the other types of problems you're going to see on your homework. We have 2 types of vocab words you're going to see in your instructions. The first word is expanding. When we think of the word expand, hopefully you realize that means to get bigger. What expanding means for us is to take one single log and breaking it into multiple logs. So this is when we're going to have problems where it looks like the left side of the property, and we're going to make it look like the right side of the property. The other instruction you're going to see in your homework is condensing. Condensing means to get smaller. So this is when we are going to take multiple logs and put them back together into one log. So we're going to look at some examples, some simple, some more complex. We're going to start with expanding. So we are expanding, which means we are taking one log, as you can see there's one log on both of these examples, and breaking it apart into multiple logs. So when you look at this first problem, log base 5 of 2x to the 6th, you should see a couple of properties. You should see that there is a invisible multiplication dot there, and there's an exponent here. When you're using these properties with expanding, we always use the multiplication and division rules first. So I'm going to make this multiplication rule, and I'm going to change it. So 1 log becomes 2 logs. 1 for the 2, and 1 for the x to the 6th. Notice this 5 goes with both logs. Don't forget that base. So there's 2 big guys, 2 logs. What does multiplication change into? Hopefully you remember it changes to addition. So that's the first step. We took 1 log, we made it into 2 logs. This log is done. There's no other properties I can use. This log is not done. We're going to take this 6 and drop it just in front of that log. Don't put it all the way in the front, just that log. So this one doesn't change. Plus sign doesn't change. The 6 comes in front, so it's 6 times log base 5 of x. And this is a done problem because no more properties can be used here, and no more properties can be used here. Okay, so let's take a look at the next problem. The main symbol you should see right away is this division bar. You should automatically be thinking the division rule. But you also have an exponent here, and you also have these two things that are attached with multiplication. So this is actually a combination of all three properties. But you got to know which order to do them in. Exponents are always last. This division bar is the main connector. So I'm going to start by making this into a division problem. So that means division changes to subtraction. So 1 log subtract a second log. So the y comes first, these guys come second. The thing is, we're not even close to being done. This first log, totally done, nothing more I can do. This second log, that's a multiplication sign. So I'm going to keep the first log, I'm going to subtract, and I'm going to change this now into 2 logs. So 1 log, 2 logs. 3 goes with the first one, x squared goes with the second one, but be careful. This subtraction sign was attached to all of this. So here's a couple of things. Multiplication changes to addition. But because this was attached to the whole log, that has to go in parentheses. Well, we're still not done. We have 2 more things we're going to do. The first thing we're going to do is deal with this little exponent here. Because we know exponents come down in front. So keep this first log. Keep the second log. Move the 2 in front of the third log. Now, the other thing that I'm going to do at the exact same time is deal with this subtraction sign. The subtraction sign goes with this log and with this log. That's an important piece. You're not allowed to have parentheses. So I'm going to subtract the first log and I'm going to subtract the second log. Now this was a lot of work and I want to kind of show you a few things that came out of this. If you notice, we ended up with 1, 2, 3 logs. Well, that's because we had 1, 2, 3 large items inside the parentheses. So 3 items, 3 logs. 4 items, 4 logs. The other thing you should notice is the one that was on top is the very first log and it's positive. The 2 that were on the bottom both have subtraction signs. -3, -x. So you can kind of start skipping some steps here. So there might be a couple of notes you want to jot down. If they are on the top, their log is positive. If they are on the bottom, their log ends up negative. So that might be helpful when we go to break things up and when we go to put them back together. Count how many items you have, write out that many logs. The top ones have positive logs, the bottom ones have negative logs. So that being said, let's take a look at one more together and then I'm going to have you try B on your own. So first of all, you look at this problem, how many large items do you see? Well, there's an X, a Y, a 3, and a Z. Yes, those 2 are separate, which means when we break it apart, 4 items means 4 logs. So I'm going to write out log base 2 4 times. I'm going to put each one of these with its own log. X squared, y, 3, and z to the 4th. Now let's fill in some plus and minus signs. X squared is on top, so this log is positive. Y is on top, so this log is positive. 3 is on bottom, that log is negative. Z is on bottom, that log is also negative. So hopefully you're like, oh, that helps make that little shortcut a lot easier. Now we're not 100% done. We do have one more step, and that's dealing with any exponents. Well, here's one. That one doesn't have one. That one doesn't have one. And here's another one. So our final answer is 2 log base 2 of x plus 2 log base 2 of y minus log base 2 of 3 minus 4 log base 2 of z. So that's how I want you guys to look at it. Count the big items, make each one of them have their own log, put in your pluses and minuses, pluses for top, minuses for bottom, and then bring down the exponents. So I want you to pause the video and I want you to try part B on your own. So let's see how you did. First, you should have counted 1, 2, 3, 4 items. So 4 logs, all with a base of 2. So 12 goes with the first one, x to the 6th with the second one, y to the 8th with the third one, and z squared with the 4th one. Where are all of these located? Well, there's no fraction bar, which means they are all on the top, which means they are all positive. Positive, 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 positive. And then your last step, 3 different exponents. This log doesn't change, plus the 6 comes in front, 6 log base 2 of x, plus the 8 comes in front, 8 log base 2 of y, plus, and this 2 comes in front, 2 log base 2 of z. So that's the second kind of problem that you are going to see on your homework. The third kind of problem is these new directions. We are now condensing. So you see many logs. We see 2 logs here, we see 3 logs here. We're going to put them all back together, and the goal is to have 1 log. So the first step, think about basically working backwards. On the last problems, where did we end? Well, we ended with the exponents. That's where we're going to start here. We're going to start by looking for numbers that need to be brought up. So this 2 and this 5, they need to go back into the exponent. So we're truly going backwards. So log base 3 of 7 squared minus log base 3 of x to the 5th. Now is when we're going to squish them back together. Our answer is going to have 1 log. Parentheses. So the big question becomes, is it going to look like a fraction? Or is it going to look like just 1 line of information? And the way you answer that, if you see any subtraction signs, you have a fraction. If all you see is plus signs, you don't. Do you see a subtraction sign? Yes, you do, right there. So make yourself a fraction bar. Anything positive goes on the top. Anything negative goes on the bottom. Is this log positive or negative? Well, it's positive, so 7 squared goes on top. Is this log positive or negative? It's negative. X to the 5th goes on bottom. And that is your final answer. Now, I will have people ask me, what if I did 7 squared and got a number instead? I will absolutely accept the answer log base 3 of 49 over x to the 5th. So if you want to change that 7 squared into 49, that is perfectly fine. So let's try another one together. So first, just like up here, look for those numbers in front. Well, here's a number in front. This one doesn't have one. This one does. Now notice I left the subtraction sign alone. Don't move the subtraction sign, just the whole number. So it's log base 8 of x to the 2nd power minus log base 8 of 5 minus log base 8 of y to the 3rd. So now we're going to squish it all back together. We're going to have one giant log with the base 8, parentheses. Because we see subtraction, we're going to put a fraction bar. Positive logs go on top, negative logs go on the bottom. So this first log, is it positive or negative? Well, if you look in front, it is positive. So x squared goes on top. This next log is negative, so the 5 goes on bottom. This next log is also negative, so the y to the 3rd also goes on the bottom. And that is a done answer. So pause your video one last time, try these last two examples, and let's see how you do on your own. Alrighty, so let's check. I see 3 numbers that need to come up. 4, 5, and 3. So log base 2 of x to the 4th plus log base 2 of y to the 5th minus log base 2 of z to the 3rd. Then make your one big log. So log base 2 parentheses. Do you see any subtraction signs? Yes. Make a fraction. This log is positive. X to the 4th goes on top. This log is also positive. Y to the 5th goes on top. This log is negative. Z to the 3rd goes on the bottom. And you are done. Let's check your last one. No number here. There's a 9. And there's a 7. So log base 5 of 6 minus log base 5 of 8 to the 9th plus log base 5 of b to the 7th. Now we need to put them all back together as one log with a base of 5, parentheses. Do you see any minus signs? Yes. There's your fraction bar. This log, positive, 6 goes on top. This log, negative, a to the 9th goes on bottom. This log, positive, b to the 7th goes on top. And that is a done problem. So at this point, you can start on your homework, and we will see you in class.